Okay, so we have two students who tried to solve this problem. If you're trying to figure out their error, what would be a good place for you to start? What should you do first? Yeah? Solve the problem. So, I want you can work and ask questions. Okay, but make sure you understand. We want to seek to understand why we're doing what we're doing. So solve the problem. Then you can go back and kind of see where they made the mistakes. Student 1 is much easier, like you can determine where they made the mistake fairly easy once you solve it. Student 2, it's kind of like a mistake you might not figure out until I show you at the very end. But you probably understand where they made the mistake. The equation's right up on top. Quick question, if you guys can have your eyes up here. Here's the equation they give you. Here's the equation I wrote down. Are these the same? Are they equivalent?
Yes.
Why? Why are they equivalent? Rachel?
Because in the first one you're subtracting, and in the second one you're adding, but instead of a positive 6, you have a negative 6, so if you add it.
Excellent. Subtracting a positive is like adding a negative. You need to remember, for today, if it is subtraction, it is really a negative. You got to remember that if it says subtraction, it's like adding a negative. All right. Talk to your groups. Remember, seek to understand. They're all here. All here. All here. All here. Boom. Okay. Make sure your name and the dates on your warm-up. Solve that problem first. Good job on solving. Remember, if you're kind of stuck, ask someone, what did you do first? So Quinn, what do you think? First step would be what? If I'm thinking of equality, right? And I'm thinking of properties of equality. I want to get numbers on one side, variables on the other. So what can I do first?
For student 1?
Yeah, well, what can I do first to solve it?
You're trying to get x by itself, so you could subtract 3.5.
Ooh, can I break this up yet?
No, sorry.
Not yet.
You could add 6 to mine to...
So I'm going to add 6, because that's a negative 6. Adding 6, what happens? Comes 0. Awesome. Right? You add and subtract to 0. That's what you want. So I added to 0. So if I add to 0 on this side, what do I do to this side? Add as well. This becomes 64.5. Then I bring down what I still have, which is 3.5x. Okay, now that I have everything gone over here, now I can try to look at separating these. How do I separate these, Si? Do you remember? Okay, hold on. Yeah?
64.5 divided by 3.5.
I'm going to divide to 1. So if I divide to 1 on this side, there's my 1. Right? 3.5 divided by 3.5? 1. So what do I do over here? Divide by 3.5. And I get x equals 18.428 or something like that. So it's 4.3. We're going to round to the hundredths. All right. Student 1. Mr. Brown, what did student 1 do?
So they subtracted 6 on the second row. They subtracted 6 instead of adding.
So they thought, hey, that's a positive 6. And yeah, they're right. It is a positive 6. But it's being subtracted, which means it is actually a negative 6. You can't, this operation stays with that. And that's why I showed you that at the beginning. So they thought, oh, positive 6 subtract 6. Nope. It's actually a negative 6, and I have to add 6. So they made their mistake right there. They subtracted negative 6 instead of adding 6. Or they subtracted 6 instead of adding 6. So that was student 1. What about student 2? Tanner.
It's pretty good up until they subtract 3.5 from both numbers.
Okay. Did they subtract? I don't know. They didn't subtract actually. This is why this is so hard for you guys to figure out what they did wrong. Well, they divide by 3.5.
They just didn't put the decimal in the right place.
Okay. Why do you think they didn't put their decimal in the right place? What do you think they're not using?
PEMDAS?
Nope. A calculator.
Oh.
Because, PEMDAS, this is why. When I get to this point right here, let's bring that over here so you can see it. That's why I knew this was going to be hard. Can I divide with a decimal? No, it's just a rule. I have to get rid of it. So how do I get rid of a decimal when I go into this? I know I cannot do this. I can't do this. I move each one over. So if I move this one over, that becomes 35, and this becomes 645. But you know what they did? They moved this one and then kept that one there. They forgot to move both decimals over. So that was a hard one because I'm letting you guys use calculators, and that student wasn't using a calculator. So, student 2 forgot to move their decimal in the 64.5. And student 1 subtracted 6 instead of adding 6 to both sides. Just a couple of things. Midterms are being sent out. So if no one in this class had a missing assignment from this unit. So that's awesome. So your grades are what your grades are. So when you get your midterms, they'll be That's literally what it says in the grade book right now. I'm going to put grades in tonight. I just didn't want to put in all the grades because there were 5 or 6 kids that didn't have their warm-ups last week. And then if I don't put the grade in, I forget. So those are always M's, and that would have really kind of skewed their grade. And I didn't want to do that to you. He's all caught up. He just didn't get, he on Friday or Thursday, he knew he had to do a day that he missed, so
that was a death list, though. You were like...
He passed it in. No, he did a great job. And the thing is, I wasn't on a desk there. He passed it in the next time he saw me. That's being responsible. Keep working hard. This is really important, guys. You guys have been doing a great job, but I want to make sure that this, we continue to seek to understand. Don't accept like, oh, you know what, I'm embarrassed, or I don't want a question. Keep asking questions. Because that's like my job. And a lot of you have great partners who can explain things, okay, really well, so keep asking them. It's really important that you seek to understand. I want you to understand the math concepts. We're solving for equality, but we're looking at it for linear equations. So we're still using those properties of equality. What I do on one side, I have to do to the other side. And then when we use equalities, we want variables on one side and numbers on the other. That's what we try to do, isolate the variable. So we're going to do that. We're going to continue with that. You will see that these are all linear relationships today. This is going to be interesting, and that's going to be interesting, because should be lots of discussion on both sides, because those are not the correct answers. So this is good. I love good dialogue. Jaden is leading one side. Josh is leading the other. And I expect good dialogue, guys. They are leading it. Josh, you lead it. And wait till everyone's ready.
Was it 19?
Uh-huh.
Can I do it? Can I use my homework class? Like, we'll go together.
Do 19. Show me tomorrow. Now, hold on. You guys can go participate. Yeah, Josh, one conversation.
This one's expired. Oh, you don't want to take that one? You're the one teacher that spells my name wrong. Everybody else spells it A-E-L.
Okay.
This one's expired, so.
Can't use it.
Expires Thursday this week, so.
So here's the thing about algebra. There shouldn't be any guessing whether it's right or wrong. What do? You put it back in for X. So prove that it's right. Come on. No. Prove up here. Prove it on the board. Allie, on the board, prove it. Ashton, make sure you're checking your work.
Oh wait, hold up. I did 10 times or 2x. Ha. No, so I can't.
Chris, you didn't do yours, or you have it? Yeah.
I have mine. Oh. And then I added that to. And then I got 8 equals 4x. And then I divided 8 by 4. So what? And that equals 2 equals x. No, but my question is. Good job. You have 6 here. 6 minus 2. So you have to add.
Yeah. 6 might. No, he's.
So I canceled this.
No, but hold on. He can do it that way too.
No, so look.
He's saying he wants to get rid of the numbers first. So he goes -6. Great, gone. -6 here. What does that turn into? -8. That's where the mistake was. You got to remember which way to go, right? Because remember, this is at -2. That's adding a negative. So -2 minus 6 gives you -8. So that's where that mistake was. Comment, Josh. Josh, that's been a super common mistake. So it's great to see. Keep talking about them.
Oh, yeah. No, wait.
Hey guys, Ashton's trying to see. You guys make a bad window.
Wait, what did you get? And was that?
6 out of 8. Good job. And then the other side, 6 out of 8 too. Good job. No, that's really good, man.
Basketball team at this time. Thank you.
Bye.
See you, Rachel. See you, B. Do it. Are we good over there now? Okay, let's talk about D. And someone else other than Ben maybe show their answer.
Who got something different for the?
How are we doing over here now, guys? How'd you do on these?
And then -6 times, and then -6 times negative. But
I see what you got. See, you got 4 and you got 8.
wait, look.
So are you adding and subtracting wrong? Oh, you can't. Okay, you can't just get the 2x stays together. But here just disappeared. You know, I'm going to work with you today because I think you need to know the steps here. How are we doing? Are we good? All right, let's find our seats then. Well, it's hard to tell because I can't really follow your work, right? That's why doing steps is so important. Some of you guys are writing down just saying, I have no idea what you're doing. Okay, we're going to pause it there. Okay, come back to your seats. All right, I'm going to start off with a teach today with you guys. So, go to 3.4. And the reason why I'm going to start off with a teach because I'm looking over at Josh's work. And I looked over at Jaden's work. And this is what I noticed. As another student, I can't look up there and see where your mistake was, like in the student 1 and student 2. Like, I can say, yeah, I got a different answer. But as for helping you understand, I can't. So this is what I want you to do, okay? So I want you to, and you guys aren't the only ones, trust me. This has been every class today. Okay, so we're going to practice doing some steps as well as there's a couple skills I'm going to show you today that you're going to need to know. So first off, right off in this problem right here, because we're talking about properties of equality in solving a linear equation. This is a linear equation. I'm going to use properties of equality to balance both sides. I'm going to get my numbers on one side, my variables on the other. In order to start, I have to change how this looks. I can't solve it like this. Does anyone remember what this 2 means when in relation to this group right here? Elise? You do. You multiply it. But what does that 2 mean? 2 groups. I have 2 groups of this. A pouch and -1 coins. If that's possible, right? So I have to redistribute press. So I'm going to take the 2, multiply it by the x, and take the 2 and multiply it by the 1. So I'm going to change this. It's going to be 5 plus 2 times x, 2x. 2 times 1, 2. And I bring down the subtraction. Do I have any like terms that I can combine and simplify before I start doing some algebra? Donna?
Wait, never mind.
You see anything I can simplify first? Can I simplify on this side? Yeah. I have a 5 and a minus 2. What's 5 minus 2?
3.
Sweet. So I'm going to simplify this to 3 plus 2x equals 12. Now, you know how I'm talking about linear equations? Check it out. There's our dependent variable. Here's our y-intercept. There's our rate. There's our independent variable. There it is, your linear equation. So now, variables on one side, Cody. Okay. Numbers on the other side. How do I do? What's the first step? Josh.
Take out 2 and 3. Or 3 and 12.
Okay, so I'm going to take out 3. Take out 3. So what happens over here?
It goes to 0.
Goes to 0. Whoop, whoop. 2x equals 9. This is where people are making their mistakes today. I can tell you that. It's when subtracting a negative, they're forgetting what to do. Adding to a negative, forgetting what to do. So just be aware that it's the subtraction that's been getting kids. So now I've got 2x equals 9. Now I do what we call divide to 1 because I need to get rid of the 2, so x is by itself. So I divide by 2. 2 divided by 2 is 1. So I divide to 1 because then 1 times x is whatever x is. Divide by 2, I get x equals 4.5. How do I check my answer? Plug it in. Put it in for x. So I'm going to do this verbally. That's 4.5 minus 1. 3.5. 3.5 times 2? 7. Because 2 times 3 is 6 plus 1? 7. So I have 7 plus 5? 12. Booyah. Okay? That's how you do it. Now, a couple things. Notice the steps. I take it slow, guys. And I write down my steps. Because now, I could give this to someone and they could be like, oh, I know it. Yeah, you know, this step right here, if I made a mistake. But if I'm just doing that, they have to walk through the whole thing with me. No, it's like, write down your steps. Okay, let's do this one. And don't forget about the distributed property. Some of you will make it that far today, given that you're going to have about 25 minutes of independent work time. This one's a cool one. Because I got pouches and coins. I have negative pouches, negative coins. It's kind of cool. So, it doesn't matter if I start with pouches or coins. I can start with either one. I'm going to start with the pouches, which are the x's, right? So I know if I have x's on this side and x's on that side, I want to get all my x's on one side. So let's say I'm going to take these pouches.
Wait, hold on.
You don't have
Ours has 4x.
Oh yeah, put an x there. Put an x on the 7. Sorry. So, how would I get rid of negative 7 pouches? Add 7 pouches. So I'm going to add 7 pouches to both sides. That side, they disappear. Now I add 7 pouches to this side. So what's 4x plus that? 7x? 11x. Minus 9 equals 13. And there you go. Right there again is a linear equation. Dependent variable, independent variable, my rate. I know my rate is always being multiplied. And man, my y-intercept. So cool. It's hidden. What do I do now?
Subtract 11 divided by 11. And then add 9.
Not yet.
Add 9 to each side.
Add 9 to each side. I want to get my numbers on one side, variables on the other. So 11x And I'm going to add 9 there, add 9 there. You notice the steps I'm taking, guys. You can see what I'm doing. That becomes 0, because I add and subtract to 0. This becomes 22. Now I divide to 1. Divide to 1 by 11. 11 divided by 11. And then divide to 1. X equals 2.
Yay.
So, pouches and coins. Remember that concept, but you got to keep in mind if they're negative or positive, because that makes things tricky.
Why wouldn't you add to 11?
Why wouldn't I add to this? I can't, because 11's being multiplied. Can't do it. I can't add 9 to that. I could add 9x to it. That works. But I can't add just plain 9. That does not work. Because that is, the like terms here are the 4x and the negative 7x. And the other like terms are the negative 9 and the positive 13. So I can only add like terms together. I can't do it any other way. Okay. Today, this is a little bit different. And you guys won't get there today, but you'll get there tomorrow. I've organized this a little bit differently. I'm going to try it out. I'm all about trying new things to make my classroom more efficient. So, record your steps. Oh yeah, I forgot to fix that. You steps. Record you steps. Substitute your answers back into the equation. Check your work. I could have taken that 2, I should have too, and put the 2 back in just to check. Because it's algebra. A1, 2, and 3. You're doing all of it. Lots of practice. Now listen, when you get here, you should have checked your work. The answers are over there on the board like they always are. Okay? Then, this is new, so please pay attention here. Allie, when you finish this part, and it won't happen today more than likely, then you go to this part. And this is going to be called my need a partner space. It's right over there on the board. You can see it. I add my name up there. And then I come back to my seat and I work on this. 51 through 53. And I'm doing this by myself. Then Josh finishes. He checks his answers. He's good. He looks up there to need a partner. He walks up. He erases my name. And then he comes to me, and then we start working on B together.
Well, if someone...
We don't work on this. This is what you work on while you're waiting. This is what you work on. Okay? And I actually have a better idea for this, but I'm not ready for it yet. But this is what you work on with your partner. That way you start the problem together. Does that make sense? Because that's where I've been going wrong, is that some of you are coming in. One person's already like 5 minutes in, and they're trying to catch them up. And I would rather you start together. So, I'm going to have need partner space work is what I'm going to call it. That means while you're waiting, you're doing this work. And I'm going to start putting it over there. And then you're going to work with your partner. Questions about that? Okay, one last thing. Skills. Yeah, we don't need to think about what makes sense. This is honestly not what we're doing. You know why? It's algebra. In algebra, we actually do that. We put it back in to make sure it works. We check our answers. We don't need to be like, is that like a good answer? No. We just put it in. Figure it out. Boom. It will tell us if it is. Okay? So check your answers. Ask questions. Okay. 5 minutes independent struggle. Productive struggle. Here we go. 5 minutes and then we'll start being able to talk. So no talking to start. Productive struggle. You have a planner? Yes? Fill it in. Planner? Fill it in. Let's go back. put this stuff away. You've had time to eat. It's been a while since you've done the homework. Do you want to do it again?
Sure.
Is that okay? Okay. Okay, you gotta wait for Ashton to come back. It's not working. What it is.
It's whistle then.
Hmm?
Expert.
Make sure to show your steps and make sure to check your answers today.
Question. So, if it would be negative 20, wouldn't there be no pouches?
Yeah, so now you got to see, pouches would be negative 5x because pouches are your variables.
Uh-huh.
This would be negative 20 coins.
Uh-huh.
That means you owe coins in that respect.
Okay.
That's why it's a little bit different. It's getting a little bit more complicated because like the whole idea of like having positive numbers, how we started is now starting to change. Now we have negatives. Got about 1 more minute of independent work time. Substitute the answer back in for x.
So,
Right? So what did you get for an answer? 2. So now put 2 in for x. So 5 times 2 is 10. 10 minus 10 is 20. So that wouldn't work, right? 10 minus 10 is 0. So you need to think, so that answer is not correct. See how cool that is? You just put it right back in.
for B, wouldn't that just be negative 2?
Could be. I don't know.
That got negative 2.
Well, think about it. You put negative 2 back in. 5 times negative 2 is 10. 10, negative 10 minus 10 is negative 20. That needs to be that's a positive 20. So negative 2 doesn't work either. That's cool. You understand that, Ryan, how you substitute it back in? So you figure out what x equals, and then you put it back, then you go up to your original equation, you put your number in, where the x is.
I don't know.
Wait, so how would you do that for like this?
So you take your 6, negative 6, put negative 6 in. 5 times negative 6,
Oh, okay.
negative 30,
Negative 30.
negative 30 plus 10.
Negative 40. I mean, no, sorry, 20. Negative.
Oh, negative 20. But isn't that cool? You get to be like, wait a minute, I did something wrong. So you're adding 10 to both sides. Oh. Remember, that is not a positive 10. That is a negative because remember, subtracting a positive is like adding a negative. Anytime you have a subtraction, that's why I showed that question at the beginning to help you prevent that, right?
I'm confused here. How do you fit 6 coins into 1/4 of a bag?
Wait. Have you checked all of A yet? Okay.
I'm on A2A.
Okay.
I
So,
checked these.
how'd you check them?
I added it back into the problem, so 5x would equal 10 if there's 2 per pouch. So x would equal 2
Yep. So you got 10. So 10.
plus 10 equals 20.
Okay. Good. Okay. So as long as you put them back in and checked. And then, so you're on B. Okay.
No, I'm not.
So you have 1/4 of a pouch is basically what they're saying.
How do you get 6
Okay,
points into that?
but here's the thing. The pouches and coins are not our learning target for today. Our learning target for today is solving for linear equations, right? Using properties of equality.
Okay.
So you can think in terms of coins and pouches, but it's not always going to make sense today because that's not what we're working on. But you can think.
Yeah, we're not doing coins.
No, but you can think that way, Josh. Okay?
I just realized that we weren't doing coins and pouches.
No, it's linear equations now. Okay, guys, you can start having those conversations. Focus on those conversations. You think you want to show your homework? Yeah, you be that dude? You haven't done it for a while, have you? You never have you?
I did it once when someone was gone.
That one day? Okay. But that's okay with you? Okay. You're going to take Jaden's spot.
I don't even know how I got this.
I signed you up. And you were a good person to sign up because you always do your homework. I really appreciate it. Okay. I'll put you up, Anthony.
Yeah, I did. Because 10 minus 5 times -2 equals 10 minus -10, which equals 20.
Wouldn't it just be 15 plus 15?
Okay, which one are you talking about?
B.
Okay, hold on.
This is right there.
Okay, so don't add 10 here. You can't add 10 to this because that's 5x.
Oh, okay.
You can only add 10 to the number.
10. And then
Yep. And then you add 10 here. Good. That becomes 30. That becomes 0. So you had it right. 5x, because that comes down, equals 30. So now you got to solve it from there. Hello, Scott. Okay, we'll do. Okay, bye. Allie, you need to go grab your stuff in the office.
Oh, yeah. Yeah, in the morning.
She's like, they'll watch it. They'll take care of it.
Wait, so hold on. I'm
Yes, so x equals 6. So you get the x equals 6, and then what you do is you come back up here.
Yeah, but what I did was 5 divided by 30, which is 6. 5
Boom.
times 6 is 30.
Okay, perfect. Yeah, and you go 5. That equals 30. 30 minus 10.
Is 20.
Boom. That works. See how you're checking? You get 20 on this side, and you have 20 on that side. That's balanced. Boom. Good work, Si.
You can't subtract it from the variable. And then you divide 6 by 1/4. And then you get that.
I realized that there's.
What is 6 divided by
24.
Scarlett, try to get going on your work. And ask questions, okay? Okay, Ashton, take your paper, come to the carpet.
Minus 10, negative 20.
Scarlett, bring your paper to the carpet, and Cyrus, bring yours to the carpet.
Okay. And then A for
All right. Let's go to problem E. E. Okay? So write down E on your board or on your paper. No, use your you can use a board to write on. Let's give one to give one to Scarlett too. All right, so I've got E is negative 10 minus 5x equals positive 20. Okay. So I've got negative 10 minus 5x equals 20. Now, I can't do anything with this until the very end. So how do I want to get the x by itself here on this side of the equation? What can I do over here on this side to help get rid of some numbers?
You can divide 10.
Not divide 10 because it's being... it's a negative 10. How would I get rid of a negative 10? Add 10. Okay, so what happens here? That turns into 0. Bye-bye. And then I add 10 here.
Which is 30.
So I get, and you want to write down these steps. So here I get 0. Here I get 30. So then I go negative 5x equals
30.
So what would I do? I want to get rid of this negative 5 that's being multiplied. Ooh, no. How would I get rid of a negative 5 being multiplied? Divide by negative 5. That turns into 1. That's gone. Divide by negative 5. So what is 30 divided by negative 5? What? Not 6. Negative 6. So how do I check my answer? Plug it back in. I go back up to the top. Plug in negative 6 for x. So what's negative 5 multiplied by negative 6? Negative 5 times negative 6? Not negative 30. Positive 30 because it's a negative times a negative. So now I have negative 10 plus 30. What does that equal? Positive 20. And look what's on the other side. Positive 20. Booyah! So I did it right. I want you guys to do F now. Okay? And then we'll go over it. So do F. Josh and Carl, come on.
Negative plus negative.
Come on, press. I want you to try it by yourself first. If you get to a spot where you get stuck, then I want you to go back and rework it. No, I just want you to try yourself. I don't have it any, sir.
20 plus 10 would be negative 30, or...
Why? What number you want? You just got to do negatives, and that's all E is about, is understanding what's negative and what isn't. Don't worry about that anymore. You can't be thinking about negative bags anymore. Pouches, it will kind of work in some circumstances, but it doesn't work conceptually. It's not going to make sense. It did when all the numbers were positive. It made total sense. Properties of equality. That's what I've been teaching you. Whatever you do to one side, you do to the other. That's what you have to do. You get it? I got it. So? Oops. So F is 10 minus 5x equals negative 20. Okay. First step, what do I do? How do I get rid of that 10?
Which that would now be 30? That's what I did wrong.
Okay, hold on. So I bring down, now this is an important thing here. This minus sign now becomes a negative sign because it's subtracting a positive, which is the same as adding a negative. So it becomes a negative sign now. It doesn't disappear. So what do I do now? I got negative 5x equals negative 30.
It'd be negative 4.
I try to get rid of this negative 5, right? That's being multiplied. So how do I get rid of a negative 5 being multiplied? Divide by negative 5. Negative 30 divided by negative 5. Positive 6. Because a negative divided by a negative equals a positive. What do I do to check?
I did it first, but then I thought I was wrong. So
That's good. Substitute it in. So here I have negative 5 times 6. That equals negative 30. 10 plus negative 30 equals negative 20. And look what's on the other side. Negative 20. Boom. This side equals that side. That means 6 is your right answer for X. Okay. Now I want you to go back and go look at A, B, C, and D. Okay?
I did A, B, and C already.
Okay, check your C and then start on D.
Alright.
Okay. I'm just going to ask a couple questions. Have you found a solution? Okay. So you're saying I got a solution. Okay. When you put the solution back into the equation, does it work?
I think she's more confused about solving, like,
finding a solution.
I don't know. Negatives on the calculator. Hey, Miss Schmidt. Oh, I know how do you do negatives on the calculator?
That one, you type the number, then put the negative. Negative's at the bottom, I think.
I got it. So you do 3, and you go flip.
Okay, so have you found a solution?
Divided by 5. I don't know.
Yes.
Okay.
Okay, does it work? So when you put your number back in for X, here's your original equation. You got X equals 2. Put it in for X. So now you got negative 5 times 2, which is... What's negative 5 times 2?
Negative 10.
Negative 10. Okay, what is 10 plus negative 10? That's 0. That doesn't equal 20. So we made a mistake.
Okay. Is it just like...
So you have a positive 10. You subtracted. You're going to laugh.
Why?
I told you, this is where everyone's making their mistakes. What's E? Copy it down. Okay. So I'm just trying to figure out where you made your mistakes. Because that's right. This is right. So now you bring down the negative 5x. Oh, you divided by 5.
It's divided by negative.
Negative 5, Ryan.
That was Presley's fault. She wrote that on my paper.
Okay. I think
It should be. The reason why is called divide to 1, not divide to negative 1. I don't want a negative 1 answer. I want a positive 1. Because positive 1 times whatever it is stays the same.
Oh, we answer negative 2?
Yep. So that's how close you were. That's good.
Wait, for E we got negative 6.
I'm a dinosaur. I take all the credit for
When we were down there.
all the wrong answers.
Yeah, because it changes her work. Trust me.
Okay.
I take all credit. I did all right. Even the right answers, but not the wrong ones.
Oh, shut up.
All right, guys. Listen. So, couple things that I've noticed around this work. How about I'm going to pose a question to you? Where are the mistakes happening when they happen? What? For you, it's your division. Interesting. Okay. I have not seen that mistake yet.
On my paper.
I said that.
I know.
Come on. Where else?
I don't make mistakes.
I'm seeing it subtracting negatives a lot.
But you're not really subtracting the negatives. You're adding.
I know, but
a negative is adding a positive.
so all right. Put your work away. We have 2 days on this. We'll definitely get to all this tomorrow. Hey guys.
I'm not allowed to call people.
Okay, starting off, thank you. Here's your homework. Jaden, you want to write this down? It's 20 AB and 21 BC.
Is it like this while working?
Yes, it is. Most of my homework, you guys know, matches what you did during the day. That's why I only sign a little bit.
Really easy.
Okay? It's on page 72. You got 4 problems to do. 2 of them you solve for X, 2 of them you solve for Y.
Okay.
20 AB, 21 BC. Okay. Next. This is a plicker. There's the work.
Please do you all work.
Okay, and guys, I don't want you telling people, do your own work. Figure it out. It's A, B, C, or D.